So this topic is called the length of a line segment. And at first glance, finding the length of a line doesn't seem all that useful. But when you think about what it actually represents, it becomes a very useful thing. So a line segment, what is it? It's just two endpoints. But if we take that and put it into reality, let's think about it. It's from maybe one endpoint is Toronto, the other endpoint is Montreal. Maybe one endpoint is your house and the other endpoint is your friend's house. What this basically does is it tells us we can calculate the distance between any 2 points as long as it's a straight line. That's where the application truly comes in. Okay, so with that in mind, how do we go about this? First of all, this first piece is a little bit of an exploration. We want to determine the length of each line segment in the figure below, in this triangle. So we have a triangle A, B, C. Okay. Now, if I want to find the length of line segment AC, so the distance from A to C, the y value doesn't change. So really it's a straight line. So all I need to do is, what's the difference from our point here to our point here? Well, the only thing that's changing is the x components. So I need to find the distance between, which is just subtraction. So in order to find the length of any horizontal line, so any horizontal line, which is AC here, so any horizontal line, we just need to subtract and find the difference between the two endpoints. So it's just going to be x2 minus x1. Now, to get the math right, you either have to think about it and say, okay, I want to subtract the biggest one. I want to subtract the smallest one from the biggest one. So it'd be 3 minus negative 3, right? Now, sometimes you may be given the points in a different order, or maybe you don't know what the biggest one is for some reason or whatever it is. There's another concept we can do, something called an absolute value, which you may have seen before. The mathematical symbol used for absolute value are two vertical bars. And so, for example, x2 minus x1. The absolute value means, give me the positive. There's more to it than that, but that's really what it means. So take whatever number's inside and give me the positive. So if I have the absolute value of negative 4, then the result of that is just 4. If I have the absolute value of 4, the absolute value is 4. So it always just gives the positive what's inside. So if we think about it like this, then it doesn't matter what order we subtract them in, because if I end up with a negative, the absolute value is still going to give me the positive, because that's all I really care about is the length of that line. Where they're located doesn't really matter. So I could say, well, x2, because this is AC. So that means going from A to C. So that'd be 3 minus negative 3. So that's a value of 6. So that is the length of our horizontal line. So it's always going to be the absolute value of x2 minus x1. BC, so that's going from all the way up here down to C. Again, this is the same idea. This is a vertical line though. So the length of any vertical line is to subtract the y components. Again, we don't know the order or anything, so we could do the absolute value again. So y2 minus y1. Oops, that should not be a curved line. That should be a straight line. There we go. Let's get our straight line back in there. So that means our y2, which is negative 4, and we're going to subtract from that 4. Now that would give us negative 8, but if we put that into absolute values, that's saying we have the absolute value of negative 8, which is really just 8. So now we found the length of that line. In what units? We weren't really given a unit. We weren't given a measurement. So when you aren't given a measurement in some question, the generic unit you use is just units. But most of the time you will be given units. All right, so now we need to calculate the line, the distance from line A to B. From A to B. But this is a diagonal. We can't really do it like this. Now you're probably looking at that and you said, that looks familiar. That's a right angle triangle. And we know that right angle triangles have two sides and a hypotenuse. And we can calculate that hypotenuse using the Pythagorean theorem, which we have right here. Now, we know when we label our triangle, C is always the hypotenuse, and then A and B could be either side, right? It doesn't really matter which one is which. So let's just kind of play with this generically for a second. Now we're trying to calculate for c, so if we rearrange this equation, the a and b stay where they are, but because we have c squared, we have to take the square root of both sides. So the value of c is equal to the square root of a squared plus b squared. Okay, so what does that actually mean? Well, it means the length of line segment AB is the square root of A. Well, if this is A down here, that's AB, the length of AB. We just calculated that over here. Or sorry, AC, not AB, AC. That's 6 squared, because that's what the equation says. We're going to add on to that the length of B. Well, that's BC. That's 8. 8 squared. Now, when we take the square root of that, what does that mean? It means the square root of 36 plus 64. Well, that's the square root of 100, which of course is equal to 10 units. So if we want to calculate the distance of any line, we're basically going to use the Pythagorean theorem. Now we're going to take all this work that we just did here and we're going to put it into one step. That's the idea. So as we saw in the example above, it can be easy to find the length of a horizontal line or vertical line. The challenge is when it's on a diagonal. So if we have the following line segments here, look down here at this bottom triangle. A at x1, y1, B at x2, y2, and C at x2, y1. Because it's just using the components from the other ones to match it up. We can actually calculate everything we need here. So our goal is to calculate the length of AB. The length of AB eventually. So let's look at this. The length of the line segment from AC, A to C, is x2 minus x1. We know that. The length of the line segment from BC is y2 minus y1. Put it in brackets like they did above, just to keep it consistent. So if we're going to use our equation up here, c squared is equal to a squared plus b squared, and keep the same idea, that means ab squared, still keeping the square, is going to be equal to our x2 minus x1 squared plus our y2 minus y1 squared. All we did was say, give me the length of the bottom line, the length of the side line. Those are our a and b. And now that means to find the AB of this whole thing, we just got to take the square root. So it's the square root of exactly what we just found. x2 minus x1 squared plus y2 minus y1 squared. Now because we're squaring everything, getting a negative no longer matters, so we don't have to worry about the absolute value anymore. So the length, or sometimes we just say the distance, because remember what we're really calculating is the distance between 2 points. The length or distance of any line segment AB can be found with the formula DAB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the key to this whole lesson. So let's try and apply it. We're going to build our way up here. So let's start off with something simple. We have 2 points. Let's just simply find the length of the line that joins these C and D together. So that means D is going to be equal to the square root of, now it's x2 minus x1. So x2 is 3 minus x1, which is 0, and we're going to square that. We're going to add on to that y2, which is 6, minus y1, which is 2, and we're going to square that. Now let's break it down. So that's 3 minus 0, that's 3. Squared is 9, so the square root of 9. Plus 6 minus 2 is 4. Squared is 16. So we have 9 plus 16, so that is equal to the square root of 25. That's a nice simple number. Square root of 25 is simply just 5. And that's our final answer, 5 units. No work involved. So let's go to the next one. Find the exact and approximate length of a line segment joining J to K and round your answer to the nearest tenth. I'll explain what they mean by exact and approximate in just 1 second. Let's do the work first. So if we have JK, we're going to follow the same formula. Our distance is going to be equal to the square root of something. It's going to be x2 minus x1. So that's negative 3 minus negative 9. That whole thing is squared. Plus, watch your negative signs. It's easy to get lost here. And now our y's, which is 12 minus 7 squared. Let's bring our line across. So this is equal to negative 3 minus negative 9. So that's the same thing as plus. So negative 3 plus 9 is 6 squared. 6 squared is 36. Okay. Plus 12 minus 7, that's 5. 5 squared is 25. So if we add those up together, we get the square root of 61. This is what's called an exact answer, which means we've done no rounding. It's exactly perfect. It is what it is. Okay? The approximate answer is where we actually calculate that. And what you're going to find when you calculate that is you're going to be given a bunch of decimal places. All right? So this is our exact answer. But when we actually do the calculation, the square root of 61 comes out to be approximately, so this is how we write approximately, an equal sign with a dot over top of it, approximately 7.8 units. Why did I stop at one decimal place? Because it said round to the nearest tenth. So 7.8 units. This is our approximate answer. Most of the time, you don't want the approximate answer. You might be like, but why? I understand that number easier than I do root 61. The reason why we don't want the approximate answer is because if we need that number in a future calculation, by approximating it, we've just introduced error into our future calculations. And that is not a good thing, because that error will then grow and compound with other calculations as we go through the problem. So we want to keep our answers in our exact format almost always, unless there's some specific reason to convert it. All right. So now let's take this idea and put it into something a little bit more closer to reality. A fire breaks out at location F, negative 1242. Imagine this is like a city block, and this is the location of a house on a city block. There are fire trucks located at 25, negative 7, and 18, negative 2. How far away is each truck from the fire? So if the fire is at F, we need to calculate the distance from F to A and the distance from F to B. And our goal is to figure out the distance of both. Okay, so that means we got to do two calculations. So we're going to have DAF, and that's going to be equal to, we got to do the whole square root thing. So we're going from A to F in this case, because I wrote it as AF. So remember, this is y2 minus y1. So this would be 42. X2 minus x1 first. I did it backwards. I apologize. So 25. No, I went backwards again. A to F. I apologize. F is going to be this is going to be our x2 and our y2. Just to be clear, because I keep making the mistake. My mistake. So x2, which is negative 12. And we're going to subtract from that 25. Then we're going to square that. Now we're going to do it for our y's. So we're at 42 minus negative 7. And we're going to square that whole thing. And this whole thing is under a square root. Woo! Okay. Negative 12 minus 25 is negative 37. Squared. We're going to add on to that 42 plus 7, which is 49 squared. This number is not going to be pretty, is it? That's okay. When we do the math here, we end up with the square root of 3,770 units. We don't have a measurement, so that's what we're going to work with. So that's the first one. But now we need to do the same thing from distance from B to F. Okay? So again, we have our square root sign, and now we're going from B to F, so this is still going to be x2, y2. So our first one is our x2, which is negative 12, and we're going to subtract from that 18. We're going to square that. Now for our y's, we have 42. Subtract from that negative 22. And that whole thing is squared. Okay. Negative 12 minus 18 gives us negative 30 squared. And over here we have 42 minus negative 22, so 42 plus 22, that's going to give us 64 squared. So we end up with, when we do the math, we end up with the square root of 4,996 units. Now, a common thing to do once we get this would be to compare these things. So if it's a fire, the question might be, okay, you've now calculated the distance from each fire truck. Which one is closer? So which fire truck should go to the fire first? And that, of course, in this case, would be the fire truck at location A, which is only the square root of 3,770 units versus the square root of 4,996 units. So clearly, truck A should go to the fire. All right, one last question, but this one's multiple steps. A triangle has vertices A, B, and C, 13, -2, 9, -8, and 5, -2. Find the length of each triangle side. So that means we got to find the length of AB, AC, and BC. You don't have to draw it. You can draw it if it'll help you solve the problem, but you don't have to. So we got to find 3 distances here. So I'm going to use all my space I can. So we have distance of AB. So that's going to be the square root of, now we go through the whole thing. So we're going from A to B. So x2, which is 9, minus 13. That's going to be squared, plus our y's, which is -8, minus -2. That whole thing is squared. And the next one, we're going to have the square root of 9 minus 13. So that's going to be -4 squared, which is going to give us 16. -4 squared is 16. Now we're going to add on to that -8 minus -2. So -8 plus 2, that's -6 squared is 36. So 16 plus 36. So we end up with the square root of 52 units. So that's distance of AB. Now let's do the next one. Let's do the distance of AC. So from A to C. Okay. Square root, same thing. So A to C. So that means our x2 is going to be 5 minus our 13 squared plus our y2, which is -2, minus our y1, which is also -2. We square that. And we end up with 5 minus 13, which is going to give us -8 squared, which is 64. And then we're adding on to that -2 plus 2, which is just 0 squared, which is still 0. So this one is just the square root of 64 units. Now, some of you will say, well, I'm going to put that into 8. And that would be perfectly fine. But just so we can compare our numbers a little bit better, we're going to keep them both as square roots because it's more clear, because I have no idea what the square root of 52 is. But I can compare the square root of 52 versus the square root of 64 and see that 52 is definitely smaller than the square root of 64. Right? If we have a need to convert it to the actual number, we absolutely will. So we have one left. So we've done AB and AC, so now we just have to do BC. Same idea. Square root. x2, so this is going to be our C, so that's going to be 5 minus x1, which is 9 squared. And we're going to add on to that y2, which is -2, minus -8. That whole thing is squared. Alrighty. So 5 minus 9, that's -4 squared. That's going to give us 16 again. We're going to add on to that -2 minus -8, so -2 plus 6 is 4 squared. Sorry, it's 6, not 4. -2 plus 8 is 6. Squared is 36. Write our line over there, and we end up with the square root of 52. Okay, now some of you will be looking at that and say, ooh, that looks interesting. Now the next question is the triangle scalene, isosceles, or equilateral? Well, in order to answer this, we need to know what all those things mean. Well, an equilateral triangle means all sides are equal. All sides are equal. An isosceles triangle means 2 sides are equal. Let me just draw an equal sign there. Might be easier. 2 sides are equal. And then a scalene triangle means no sides are equal. So if I ask you to classify a triangle, I'm asking you to look at each of the length and say, well, which one is it? In this case, we can see that we have 2 sides that are equal. We have AB has the same distance as BC does. So AB has the same length as BC. So this would be an isosceles triangle. So the triangle is isosceles. Oops. Now, it's almost always going to want you to justify that. So we could say, since two sides are equal. Great. Is the triangle a right triangle? Okay, I'm going to scroll down for this one. Is the triangle a right triangle? Don't worry about that stuff. That's the next lesson. Is the triangle a right triangle? Now, there are multiple ways to solve this problem. Okay? And if you know the distances of all three sides, that makes life a lot easier. So there are two strategies. Strategy number one is plug your side lengths into the Pythagorean theorem, and if left side equals right side, do a left side right side check, then it is a right angled triangle, because the Pythagorean theorem only works with right angled triangles. So option number one is Pythagorean. So which is a squared plus b squared is equal to c squared. You just have to know which one to use. You know the rule of thumb is the hypotenuse is always the longest one. So you got to make sure that the longest of the three sides is your c value to make this work. In this case, square root of 64 is the biggest one. So we have a squared plus b squared is equal to c squared. Doesn't matter which of the other ones are? Nope. In fact, it double doesn't matter this time because they're both the same length. So what we're seeing here is we have the square root of 52 squared plus the square root of 52 squared is equal to the square root of 64 squared. So if we write this out, that's just equal to 52 plus 52. On the other side, we have 64. So this is 104 equals to 64. No, it most certainly does not. So since the left side does not equal the right side, therefore, it is not a right triangle. Okay. Now, how else could you solve this problem? Well, you could solve this problem in another way by checking all your slopes. If you calculate the slope of all three of your lines, you have to look at the values of the slope, and you're going to look for a negative reciprocal. So option number two is find the slope of each line. Find the slope of each line, and it is right angled if any two are negative reciprocals. Are negative reciprocals. Okay, so how do I actually find the slopes? Well, you have to do rise over run for each one. Okay, so let's do the work since we're on a video and we have infinite time on the video, whereas in class we don't have infinite time, but we'll do the work here. So if I want to find the slope of AB, that's going to be y2 minus y1 over x2 minus x1. So where are we here? So AB. So y2 is negative 8 minus y1, which is negative 2. And that's over our x2, which is 9, minus x1, which is 13. And that's going to give us negative 8 minus negative 2. So negative 8 plus 2, that's negative 6. Over 9 minus 13, that's going to give us negative 4. But we can reduce that and get rid of both negative signs, so it becomes just 3 over 2. So that is MAB. All right, let's go to the next one. So the next one is MAC. So now we're going from A to C. So y2 is negative 2. Subtract y1, which is also negative 2. Okay? And we're going to do x2, which is 5, minus x1, which is 13. And when we go down another row, we got -2 plus 2, that's a 0, over -8. No matter what, that's a 0. Okay, so that slope that must be a horizontal line. Alrighty, and then finally, we have our MBC. So that's going to be our y2. So now we're going from B to C. So our y2 is -2 again. And we're going to subtract from that our y1, which is -8. Okay. And just give me 1 second. Yeah, that's right. And now we do the same thing for x's. So our x2 is 5. And we're going to subtract from that our 9. And we calculate. So -2 minus, so minus negative, which is plus. So this is going to give us 6 over 5 minus 9, which is going to give us 4. -4, sorry. So this gives us -3 over 2. Now you're going to look at that. Oh, that's very similar, but it needs to be a negative reciprocal. Those are just negatives of each other. So since we have no lines with negative reciprocal slopes, it is not a right triangle. Okay? Since no slopes are negative reciprocals, it is not right angled. It's not a right triangle. It is not a right triangle. Okay, now you look at these two, and you tell me which one is least work. Definitely the one on the left. As long as you have those distances, the one on the left is the option to choose. Less work, less chance for error, great. The one on the right, a lot more chance for error, because it's easy to mess up your negative signs. Very easy. How many times did I do it during this video? Okay, so that's it for our distance or our length of a line. One more lesson in the unit.